So viewers, today we have a very interesting topic, the three-body problem and Lagrange points. So what is the three-body problem and Lagrange points? This problem will be addressed secondly, but firstly we need to address some basics. So as we know that in real life there are n body system, as we have many celestial bodies which are revolving around the sun. But for simplicity's sake, we will be taking two-body problem in which we consider our masses as point mass. The Earth in this case is revolving around the Sun. So to solve this problem, we would need to reduce the number of unknown variables. So the most important thing that we need to cater is the reference axis system and its placement. Now let's consider two bodies in orbit. If we place our axis system about this center of gravity, then we can reduce the number of unknown variables. Due to this reduction in unknown variables, we can solve the Newton's gravitational law and analytical solution will be possible. But what if we have n bodies or three bodies?
As we can see here, the random motion of three bodies will give a large number of unknown variables which cannot be solved analytically. And for this reason, we have a special case in which third body is considered as a point mass with negligible gravitational force. This case is called the restricted three-body problem. An example in the real world can be found as a satellite as a point mass with two bodies, Earth and the Sun. And we can imagine easily that satellite has very small mass and gravity compared to the Sun and the Earth. So this approach is quite useful. Now this point mass can exist in the orbit if it is at 5 certain locations. These are called Lagrangian points.
This picture represents all the Lagrangian points. First Lagrangian point is called L1. As you can see, it is located between Sun and Earth. The gravitational pull from Earth and Sun make the body stay at this location. L2 is point located behind the Earth. It is kept at this point due to attractive forces of Earth and Sun. L3 is point located far away behind Sun. It is kept there due to gravitational effect of Sun. L4 and L5, the 2 points are equidistant from Earth and made 60-degree angle with respect to reference line between Earth and Sun. Now I will discuss the gravitational effect on L4, which will be same for L5. Earth will be attracting L4 towards itself, and same case is for Sun, which can be seen from these red arrows. The resultant gravitational effect will be represented by blue arrow, and this force make this point very stable. Now we will be discussing the significance of each point individually. L1. Due to its location, it will be illuminated by Sun throughout its orbit. L2. The sunlight will be blocked due to presence of Earth. This point is significant for observation of universe as it pick up light from distant stars. L3. It is blind spot if viewed from Earth, so currently not used for observation purposes. L4 and L5. Most stable points. So these points will not be affected from slight disturbance by other bodies. This gives the visual representation of these points in motion. The asteroids due to presence of Jupiter are at L4 and L5 points, and these are stable. So these will remain in their orbit without destabilization.
Now we take you through the asteroid belt at the L4 and L5 point located due to the presence of Jupiter. Hope you enjoyed the video. Please like and subscribe.